Okay, so this is an Ender 3 V2 Neo, and we're going to do the direct drive conversion on this. And I found this bracket on, I think, Printables. Prints like this, really, really nice. No supports needed. Super, super, super clean. And this will be the one that you can use with your factory metal extruder. Um, so what we got to do now is we need to get in here with this wrench. We need to loosen the carriage where it wobbles. Okay. And once we do that, because we don't want tension on that while we're trying to take it off, we're going to need a bunch of different Allen wrenches. The ones that will come with the kit will be sufficient to remove this. So basically, I think on this one we just have this one right here, and we're gonna have to see if we have enough cable to make this thing reach. Also, if you haven't done so, you're probably gonna want to preheat this thing, pull the stuff out. So I'm going to go ahead and do that right now. I'm waiting for the Sonic pad to boot up, and we get that plugged in here. So I've not really found that this print's really all that great one way or the other. So I don't feel like we have a whole lot to lose here. So we're going to heat this up in a second as soon as the stupid Sonic pad comes on. I really am not a fan of this thing. Because now this printer is dependent upon the Sonic pad. But anyway, we got that there. There's some little tabs here that lock in. And you will see them if you look carefully. So basically, I can't remember if there's another screw here or not. Okay. Preheating. An abnormal interruption was detected. Okay. Still trying to get this damn thing off of here. Okay. So the tab is right there. Just take like an Allen key, push it in there, and then there you go. So you gotta release those two tabs, and then you can get the fan off of here. And we're just waiting to see what temperature we're at. We're at 111 Celsius, so we gotta wait a while. Okay, so in the meantime, we could get an Allen wrench in here, and I think it's going to be this larger one. Yeah, so if you've got like an 8mm ratchet or whatever, you can use that too. I'm going to just loosen these. I wish this thing, I noticed that on these particular printers they easily push up and down, but with dual lead screws they don't. And so that's another thing I want to do to this printer, is I want to upgrade the lead screws. Okay, we're at 234. Just as I do it. I don't even bother going into the program to do it. Sometimes it just retracts too slow, and then you could actually end up with crap in there, plugging everything up. So, okay, we got that. So now we can go close out everything. I just click the emergency stop on the Sonic pad and then just shut the printer off. Okay, so this is going to be hot, so we got to be careful while we're working around it, but let's go ahead and move this one over here. I like to get these to where they're almost all the way out before I mess with them, because they have nylon locks on the end. This wrench that comes with this is kind of primitive. So as soon as it, come on, we got to make sure we hold it good at this point because it's going to want to fall. Between that and dealing with the carriage moving. So what we'll need to do is you need to deal with those spacers. That's a good time to check your palm wheels and see if they're bad, if they need any attention. So you have these spacers here. They may or may not fit, okay? If they don't fit, you're going to need to get a drill bit, like a 5/16. So, like mine don't really want to fit. So, I've already done this before, so we'll just take this. And just be really careful because if it decides it wants to take off, and you have a drill with nice torque, it's going to hurt you. So that should be enough right there. And if it's not, then we'll just go back through again. That one almost fits. And I pushed them out with something like this because I'm going to go through it again. I don't want them to fit in there too tight. I want to be able to take them out later on if I need to. What's annoying is that they didn't print this thick enough, so basically we've got this thing here that could possibly potentially move back and forth because now this thing is not actually in there very well. So we may actually need to print another one of these. I don't know. Another thing I can do is probably put like a piece of tape inside of here real quick, or just something like even a piece of filament that is from like a test. Or you stick it in there like that, and then clip it off or whatever. Let's see, where's my clippers? I just want it to where that thing's not going to vibrate around in there, because they didn't make it to where this design is as big as the spacers. So what it means is that it's going to snug down on the spacers, but the adapter is going to still be able to move, which I don't like, but so now we get that there like that, and what's nice is this doesn't seem to interfere with anything so far. I'd like to change the design and make the plastic a little bit thicker maybe. I don't like how they have it, and then you either really got to like press it in. Oh, that does not want to thread. That's interesting. Okay. That one done. We're gonna need to clip the other stuff here shortly too, because we gotta remove or cut the Bowden tube, because can't have it. It would be a good idea too to switch this to Capricorn tubing probably. So now we've got that on there. Tired of fighting this thing. Okay, so now I'm going to snug up the eccentric on the bottom here. Okay. And then I need to remove these. Or at least that one. So now, I probably should have pulled this first, but actually what I'm going to do is I'll sacrifice this after I get it out of there. We need to get this clip out of here. Okay, and then we got to come over here on this side and undo this. And you might be able to split part of this ribbon without having to add an adapter. So some of these you're not going to be able to get to until you start to take the rest of it apart. And they're not all the same size. I don't think it's this size. Nope. Okay. I gotta figure out what I did with the other one. So the arm, gotta push on it while you undo the screw, because there's a little tension on it. And once you get it out of there, then you can deal with the rest of it. Hollow. Wow. So I never actually seen one of these before. I didn't know they were hollow. There's actually this other little screw right here that they have that wouldn't be on an aftermarket one, which forces it to be hollow. And I'm not really sure what the reason is. But if we run this one in all the way, I think we can get this one out. If I'm wrong, we'll have to come in and remove it. And then just make sure you're holding onto the stepper motor when you pull the last one. Look at all the shavings here. So this is probably more of a candidate for a dual gear, but we'll get into that later. So for now, what we want to do, I'm going to take this and see if it'll work. This is also hollow. Look at that. Hollow. They put this little screw here, and I guess that their idea was it would stop it from traveling too far one direction or another. Interesting design. Okay. Anyway, the aftermarket ones are completely solid. But so if you're interested in doing dual gear, you'll see here that it comes out in a different spot. You will not be able to use this bracket. You will need to get one that's adjustable or offset by a bit. But we're just going to try this one for now. We're going to go pull our tubing here, and then we'll take our stepper motor and we'll make sure that it's going to fit. Okay. But you can put it like that. Should be able to put it like this, which will be a little bit easier. And then just take this and shred it, pull it. This is going to go all the way to the top. So basically, take this gantry and move it all the way, okay? And then take this and make sure that it can physically reach. Okay. Because what will happen if it can't, if for some reason you print something really, really tall, it's going to pull it out. We can see here that it'll reach. So we don't even need to change anything. So basically, we're good. And then now, we need to figure out where this needs to be cut at. And let's get these screws out of here. So if we look at this right here, you can get a pretty good idea. Somewhere right about there. I'm not going to sit here and worry about it too much because this stuff is cheap crap. And really, we don't even want it. So let me, it likes to collapse too. When you cut it, it kind of, so pay attention to that. Now, what to do here, we'll set that there. We'll run this in here, and then you're gonna have to release it and get it to where it needs to be. So you just push on the little clip. If you can't, you might need to get pliers in there. Good. And just get it to where it's pretty good. And then put your stepper motor back in here. And then I would start with the, I don't know what you call that, chamfered one first. And it looks like the 3D part, the holes that are printed aren't really the greatest in the world. So we're probably going to run into problems. And it's probably going to not want to fit. So I'm going to go ahead and step back for a moment and go like this to it. And I just want to make sure that, in fact, if I could find something maybe a little larger. This is just called being resourceful, okay? So let's put this motor right here out of our way. Okay, so one of the other Allen wrenches that comes in the kit, which is not labeled, I don't know what size it is just slightly a little bigger. And so by putting it through these holes, we're going to make them a little larger, just easily enough. Like, I think they almost printed it in such a fashion that they intended them to kind of thread, but because it's still a tight fit. And I don't want to drill this because I've already got it mounted on top of here, but I might have to. So since it's already kind of like wanting to thread into the plastic, I put the stepper in there first so they can thread it into the stepper without having to fight the plastic trying to self-tap. I don't know if that makes any sense, but if you've ever screwed two pieces of wood together, and you'll notice that like it doesn't tighten to the bottom one because it's still tightening to the other one. Okay, so that actually fits really nice. And then I think the next one is going to be probably over here. We'll do that one. I think that's this one. Or this one. Wait. Okay, so we have the arm and the spring over there. And so this one here, you don't put anything there. There's another one here and another one there. And so out of the four, you'll have only 2 screws that are exactly the same. And like I said, one is got the recessed head. Another one is longer than the rest for the arm. The other 2 are the bottom ones. So now I printed this bracket on the Elegoo Neptune 4 and it came out pretty good. I printed a similar bracket a different way on the Solvol. Came out pretty crappy. Right now the Neptune is just finished printing something, which I've been trying out lots of different brackets for these guys. So probably maybe I'll do like a video on the ultimate like Ender 3 direct drive conversion. The problem is all these Ender 3s are all different. So this is a V2 Neo and it has a different hot end, and the nozzle is basically almost in the middle, and spaced out a little bit more than these other ones. Okay, so we got that there, and now we just need to deal with our spring. And the other problem is, okay, I didn't even think about this at the time, but you can't get to this down here anymore. And this is the tensioner. So I'm wondering if I can get to it with a ball end hex key. If I can't, it will actually end up having to remove everything. Okay. So there we go. Just barely. So you will no longer be able to tension this thing at all. It ain't gonna happen. If you took one of these and cut it like right there, you might be able to get in there with it. But I've generally found that it doesn't make any difference. They probably come already too tight to start with. So if we need to tighten it, we'll figure out something else. I'll come up with some other idea. Okay, so now there's actually there's that bolt they put in there. I guess they put it in there for that reason, huh? Kind of nifty. So you can lock it in, I guess. So the black and red, I think, looks pretty nice on this. Okay. Now another thing is our spool is facing the wrong direction, so we could just flip it around, I guess. And that should solve that problem. Okay, it looks pretty good. We should be able to go ahead and get our fan back on here. And I do believe that they didn't give us a provision to return our screw, or did they? Oh boy. So this is going to be fun. So, okay. Well, the nice thing about this print head is it actually does snap on, and that makes it a little bit easier. And I did something with the screw, and I used it on this because they're all the same. So, so I'm going to try and see if I can get into the back of this thing or not. I might actually have to use a different screw in the first place to secure this. Okay. Look at that. Overly complicated. Thank you, Creality. Okay. So, looks pretty good. If there's something really bad happens, it'll probably just undo. You can certainly kind of bring this a little further over. I think maybe moving this wouldn't be a bad idea. See, the thing is, with this like that, if we attach this right here, if I just take this and attach it right here, okay? It's never going to be able to do anything. So what we'll do is we'll undo this zip tie. It will zip tie the extruder wire right in there. I try to always reuse zip ties whenever possible. Okay. One time, I stabbed the crap out of my hand doing this. So if I do it right now, it's actually safer to use something smaller like this. Come on. Boy, this thing does not want to come out. Might not be able to get this one. Good Lord. I don't know why this one doesn't want to come undone. Man. There we go. Okay. So we get that unclipped. Now, let's take this. Before I do that, I've got extra zip ties laying around that I want to use up because they're not really worth anything. Okay. All right. So now we're going to run it up one more time just to see what it's going to look like. Why is this printer still on? Wow. Okay. So it needs a little bit more. This is why I did that. Okay. All right. Might be easier to actually remove that. It might even be possible to fish a little bit of it out of the bottom. I don't know. But pretty tight fit. See that? So, okay. I just want it to be able to go all the way. I'd like to see a little more slack than that. But it's unlikely I'm ever going to do that. The other option here is to just actually put this a little further away. I think I'm going to do that because I don't like where it's sitting. Come on. I've had it with this thing. I got extra ones. Who cares? So And I'm going to leave it just kind of loose there. I don't want it like cinched down. And that way if it needs to move a little bit. But that's a little bit better because now it'll be able to move. I mean, the printer is never going to go this high, but if it does, I'm not pulled tight like I was before. So I think we're pretty much good with all this. We're going to flip this around and do all that, but so that's how I did this. And these brackets, you know, I mean, like you can get all sorts of different ones. This is an adjustable one I need to reprint, but I don't like how it came out. And so basically you can slide it over. So if you have one of these larger dual gear extruders, if you look right here, the dual gear is going to come out quite a bit further actually. So I mean, you could, you know, make it work maybe, but the Bowden tube is only like that long. So it'd be a pretty sharp angle. So anyway, thanks for watching. I hope that helps with anybody that was curious about doing this. I'll leave a link to the STL file. So catch you guys later.